Okay, so we're starting with simplifying rational expressions, and the reason why we do this unit right after the polynomial unit is because we're going to factor to be able to simplify these rational expressions. So let's start with filling in that blank there at the top. It says a rational expression is a ratio of two polynomial function or expressions. That's where this word comes from. Ratio is in the word. That's where rational expression comes from. Ratio is another way to say fraction. So to simplify a rational expression, step number 1, factor everything that we can possibly factor. Step number 2 says simplify the monomials, use the exponent rule. So that's like if we have anything in front, we will simplify those. And then step number 3 is to eliminate common binomial factors. So that's really wordy. What that means in more everyday terms, we are going to cancel anything that shows up exactly in the numerator and denominator. Okay, anything that shows up exactly the same in the numerator and the denominator, you are allowed to cancel those. That's what it means by eliminate common binomial factors. It sounds all official when you say it that way. All right, so let's look at example number 1. There's nothing to factor there. Those are monomials. There's no factoring to be done. So we are just going to simplify. We're going to simplify 20 over 14. Now, if you can do that mental math, that's great. If not, use your calculator. 20 over 14, you know it doesn't divide evenly. So turn it to a fraction. Math, enter, enter. We get 10 over 7. X to the 6th over x squared, we use our exponent rules. Exponent rule says when we divide, we subtract those exponents. So 6 minus 2 is 4. So 10x to the 4th over 7, that's our final answer. Now, these are going to be multiple choice questions on the final exam. So let's look at a little strategy for handling that. We can graph the original. Now, there are 2 ways to put this in. The easiest way is, since it's a fraction, the first thing you should do is hit the division symbol on your keyboard. And look, it automatically starts that fraction for you. Type in the numerator there, 20x to the 6th. Type in the denominator, 14x squared. Okay, that's what our function looks like. Let's type in what we got for the answer, 10x to the 4th over 7. Okay, and notice I've shown you how to do this before. You click the color there, and it should look exactly the same. If it does not look exactly the same, then it's not the correct answer. So for example, say you messed up your exponent rule. Say you added instead of subtracting. Okay, what if you got 10x to the 8th instead of 10x to the 4th? Notice those are not exactly the same graph, so these 2 expressions are not equal to each other. But if you do it correctly, they should be exactly the same graph, which means that they are equal to each other. Okay? All right, let's look at number 2. 6k minus 36 over k minus 6. The first thing that we should always look for when we factor is a GCF. Do those 2 terms in the numerator have a factor in common? They do. They are both divisible by 6. So when we factor out the 6, we're left with k minus 6. Check it. Multiply it back out. 6 times k is 6k. 6 times negative 6 is negative 36. Now, just for clarity, I'm going to put parentheses around what we had in the denominator because there's nothing to factor out of the k minus 6. There's no GCF. It's not a quadratic, so it's not factorable in that way. I want you to put those parentheses so you see that those are exactly the same expression. When they are exactly the same expression in the numerator and in the denominator, you can cancel those. And all we're left with, in this case, all we're left with is the 6. So, a little weird. Our variable is completely gone. Let's check it. Do remember that when you type this in to Desmos, we always use X. Don't use the letter that they have in the problem. It doesn't like that. Always use X. So there's the original. And we said that that's equal to 6. And I mean, you can see at this point that it's just a straight line at 6. Don't forget, if it's just a constant, just typing in the 6 won't do anything. You have to type in y equals for it to actually graph it. But you can see, there it is, exactly the same graph. So yes, that is equal to 6. What that means is it doesn't matter what the value of k is, this ratio, this rational expression, is always going to simplify to 6. If k is 2, if k is negative 5, if k is 100, it's always going to simplify to positive 6. Okay, let's look at number 3. We've got y plus 8 over y squared minus 2y minus 48. Okay, y plus 8 in the numerator. Nothing factors there. There's no GCF. There's nothing to factor, so I'm just going to put parentheses around it. The denominator is a quadratic, so we can factor that. 2 sets of parentheses. Y times y is y squared. What multiplies to give us negative 48 and adds to give us 2? Well, that's 8 and 6, and it's positive 8 and it's negative 6. Now, here's a good thing about a lot of these problems. There's almost always going to be something that cancels. So if you're trying to figure out how this bottom factors, use the fact that the numerator is already y plus 8. The numerator is already y plus 8. So the question is 8 a factor of 48? It is. So 8 times 6. And then if that's a positive 8, would that be a negative 6? Would that work out? It does. Check it. Y times y is y squared. The outside is negative 6y. The inside is positive 8y. Negative 6 plus 8 is positive 2. And 8 times negative 6 is negative 48. So it works out. So we have y plus 8 in the numerator. We have y plus 8 in the denominator. You got to be careful with this one. When you cancel everything that's in the numerator, that y minus 6 does not move into the numerator. It's got to stay in the denominator. So we've got to put a 1 in place of the numerator to kind of hold the place there. The y minus 6 does not move. And again, we can check that. We definitely don't want to use y. X plus 8 over x squared plus 2x minus 48. Okay, I can't see it right now. I need to zoom out so I can actually see the graph. So I can see it there. And then we said that simplifies to 1 over x minus 6. We can see that that's exactly the same graph. If we incorrectly didn't put that 1 over, look at what the graph looks like. X minus 6 is a line. That's definitely not the same as that original rational expression. Okay? So just be aware of things like that. All right, let's look at number 4. First thing we always look for, GCF. Number 4 does have a GCF. That entire numerator, every term is even, so that means they are all divisible by 2. So if we pull out a 2, we get r squared minus r minus 20. Over the denominator has a GCF of 8. When we pull out that 8, we're left with r plus 4. That numerator will factor further. R times r is r squared. negative 5 plus 4